So in this lesson, what you're going to learn how to do is add and subtract rational expressions. Then towards the end, we're going to look at how to simplify what we call complex fractions. First of all, adding and subtracting is really easy if you have common denominators. So that's where we'll start. In example 1, notice that our denominators are both 2x. So since that's the case, our answer is going to have a denominator of 2x. Then we simply just do the operation in the numerator. In this case, subtract 3 minus 7. And 3 minus 7 is negative 4 over 2x. And notice both the numerator and the denominator can be divided by 2. So we always want to simplify our final answer. And we would get negative 2 over x. All right. Again, this second example, look at your denominators. We've got x minus 4 and x minus 4. So since those are identical, we know our answer is going to have a denominator of x minus 4. Notice here we're adding, so we will add 3x plus 6. Okay, there is one more step here. I noticed that in my numerator, 3x plus 6 have a common factor of 3. So I'm going to factor out a 3, and I'm left with 3 times the quantity x minus 2 over x minus 4. Alright, so pretty straightforward if your denominators are the same. Let's see what happens if we do not have a common denominator. We've got to make one. So we've done this when we had fractions. Like if we want to add 1/3 and 2/5, well, we can see our common denominator there is 15. So to turn 3 into 15, I've got to multiply by 5. If I do that in the denominator, I also need to do it in the numerator. In the left fraction, or the right fraction, I've got to multiply by 3. So we're going to turn this into 5/15 plus 6/15. Now that I've got my common denominator, I can just add the numerators. So the same idea still holds when you're looking at rational expressions. Really important. Your first step is always to factor the original denominators. Then you can figure out what your common denominator will be, and you can multiply both the numerator and the denominator to get that. All right, so let's look at example 3. Notice we can factor this denominator. So I'm going to leave the first fraction the same, and then in that second fraction, 6x cubed and 3x squared both have a 3x squared in common. So if I factor that out, I'll be left with x plus 1, or 2x plus 1 rather. I have to get 6x squared, so I need 2x to get that, and then plus 1. So I notice that this fraction on the right has this 2x plus 1, but my first fraction is missing that. So if I multiply this fraction over here by 2x plus 1, and I have to do that in the numerator as well to keep things the same, that's going to give me my common denominator. So this numerator, I can FOIL or distribute that 4, giving me 8x plus 4, and then my denominator is going to be 3x squared times 2x plus 1. I didn't really change anything in that second fraction, so I'm just going to rewrite x over 3x squared times 2x plus 1. Now I have a common denominator, so my final answer will have this 3x squared times 2x plus 1, and I can add my numerators. So if we look here, I notice I have 8x plus x, and that's going to give me 9x, and then I just have that plus 4 there. There's nothing else I can factor here, so this is my final answer. Okay, let's look at one more example where we have different denominators. Okay, again, your first step, always factor the original denominators. So in this denominator, I am trying to find two numbers that multiply to 9 and add up to 6. Well, if you think about that, it's going to be 3 and 3. So this is going to factor into x plus 3 times x plus 3. All right. In my second denominator, I see there I have a difference of squares. X squared and 9 are both perfect squares. So that'll factor into x plus 3 times x minus 3. All right, so now I want to see what each denominator needs to have multiplied by it to get a common denominator. So if I look at this denominator here, I notice that I have x plus 3 and x plus 3, but this one has an x minus 3 in it. So to get a common denominator, I'm going to have to multiply this fraction, the top and bottom, by x minus 3. Okay, so now I've got the x minus 3 involved over there. So if we look here, now I notice that this denominator only has one x plus 3 factor. So that means I'm going to have to multiply the top and bottom of this rational expression by x plus 3. Okay, so if we do that, we've got a pretty long common denominator here, but it is x minus 3 times x plus 3 times x plus 3. Okay. In our numerator, what we're going to do is FOIL out this right here. So we're going to take x times x, that gives us x squared. X times 1 gives us 1x. Negative 3 times x is negative 3x. And negative 3 times 1 is negative 3. In this second fraction, I've got minus 1x. And then I also have minus positive 3. If I'm subtracting a positive 3, that's just minus 3. And now I see what like terms I have in the numerator. So first thing I see is I have minus or positive 1x and minus 1x actually cancel. And then I have negative 3 and negative 3 would combine to negative 6. So my final answer, my numerator is going to simplify down to x squared minus 3x minus 6. And my denominator is still x minus 3 times x plus 3 times x plus 3. All right, so there's nothing else I can do with that. You might think about factoring this numerator, but if you would try that, you'd be trying to find two numbers that multiply to negative 6 and add up to negative 3. And I don't think there's anything that's going to do that. So this right here is our final answer. Alrighty, so we can't do that. Okay, last topic in this lesson is complex fractions. In short, a complex fraction is just a fraction within a fraction. So it's like fractionception. To simplify these, we can just rewrite them as single fractions in both the numerator and the denominator, and then we can just turn it into a division problem. So let's do that with a really simple example to start off. This example 5 is the same thing as 3/5 divided by 2/7. So this fraction bar in the middle, you can just turn into division. All right, whoops. So remember, a division problem, you can just turn into a multiplication problem by keep, switch, flip. So we're going to keep the 3/5, switch to multiplication, and flip the second fraction. So now we can just multiply straight across. 3 times 7 is 21, and 5 times 2 is 10. So we get 21/10, or 2.1 if you prefer a decimal. All right, our next example is going to be a little bit trickier. We're going to throw some variables in here. All right, so first step, let's turn this into a division problem. So I'm going to just write 2x over x plus 3 divided by 5x squared over x minus 2. Okay, so let's keep switch flip. 2x over x plus 3 times the reciprocal, x minus 2 over 5x squared. All right, so now I'm going to see if I have anything that can reduce. So I notice that if I cross reduce, this x is going to cancel out one of the x's down here, so it'll reduce down from 5x squared to just 5x. Now I'm just going to multiply straight across. So in the numerator I have 2 times x minus 2, and in the denominator I have 5x times x plus 3. And I don't see anything else that is going to cancel there, so this is my final answer. All right, one more example here, and this one is a tough one. All right, so lastly, whenever you have an addition problem in either the numerator or the denominator, that's what you've got to do first. So what we need to do is rewrite 1 over x minus 4 plus 3 over x plus 1 into a single fraction. So right now it's 2. All right, so we're going to do this off to the side here. All right, so some side work. I'm just going to rewrite my 1 over x minus 4, I'll leave some space, and 3 over x plus 1. So I've got to find a common denominator first. When in doubt, you can always multiply the fractions by the other fraction's denominator. Meaning I'm going to multiply this fraction by x plus 1, the other denominator, and I'm going to multiply this fraction by x minus 4. So we're just multiplying one fraction by the other one's denominator. Okay, let's simplify things a little bit here. So my common denominator is now x minus 4 times x plus 1. Okay, my first numerator, if I distribute 1, it's not going to change anything. I'm just going to have 1x plus 1. All right, and in my second fraction, I've got x plus 1 times x minus 4 in the denominator. If I distribute this 3 in the numerator, I'm going to end up with 3x minus 12. All right, so now I've got my common denominator, x minus 4 times x plus 1, and I've got some like terms. X plus 3x gives me 4x, and 1 plus negative 12 gives me negative 11. Right, so that's not my answer, but that is what I can rewrite the denominator as. So I'm going to go ahead and turn this into a division problem right away. I've got 3 over x minus 4 divided by this. So I'm going to use that fraction right there. All right, so 4x minus 11 all over x minus 4 times x plus 1. Okay, so now let's keep this separate here. We can change this into a multiplication problem. We're going to keep the first fraction the same, switch to multiplication, and flip the second fraction. So x minus 4 times x plus 1 will be in the numerator. 4x minus 11 is in the denominator. And if we check here, we've got x minus 4's will cancel. So we'll be left with 3 times x plus 1 in the numerator. And we've got 4x minus 11 in the denominator. I don't see any other common factors that we can take out.